Good evening, everybody. Let's just get started with today's class. If you have any questions, let me know. So in the previous class, we talked about constraints, and constraints basically um, allow us to put restrictions on the data coming in or validations. Basically, we can put different kinds of constraints to get only valid data inserted into the table. And that's how we created some constraints like not null, primary keys, and unique keys, check constraints, foreign keys, and references. And we talked about all those things. So let's create a table and we'll talk about default values for this table columns. The data which is going inside. Um, if we are not providing values, we should have some default values put in. So then it's like a placeholder, and then we can update the values later on. So let's talk about defaults today. So let's create a table. Let's say create a table called, let's say, defaults test. There's a table called defaults test. And what we will do here is we'll create this table with a bunch of columns. First of all, we need a primary key. So ID. Let's say, for example, row underscore um, identity. Okay. And this is a number data type. Okay. And we'll make this a primary key. So that means we will not allow nulls or we will not allow duplicates in the row identity column. So basically it's just to identify a row. Now, what we'll do is, let's say, for example, there is a product underscore name. This is a varchar data type and it's 20 characters. Okay. What if we don't know the product name when we are inserting the data? Okay. Let me create other columns here. Let's say, for example, product underscore price, and it's a number data type, and it's a 7,2 data type. And also, let's say, for example, when was the row created? Let's say, for example, row created date. Okay. So this is a date column, and basically here, um, so this is how we'll create a table, right? I just wrote the create table command. So what we'll do here is, let's say, for example, when we don't provide product name while inserting data, we want some default value to go into the product name. So let's say, for example, how do you write default here is default value. In the brackets, you provide what is the default you want. Okay, so say, for example, unknown is the default value. Same way, you want to specify some price. Say, for example, default price. Because this is a number, I can just do a 0, or let's say, for example, I can do a minus 99.99. Okay. You have to be careful, like whether you want to sell this way or not. But I just, for example, I'm showing you what is the default value. And for date, you can say default value is, you remember sysdate function where it will get the system date and put it in. So basically sysdate will return what is the current system date. And when you make this a default value, basically this column, if you don't provide value, it will store whatever is the default date on that day. So now if we create this table, let's just run it, and you can see the defaults test table has been created. So what we'll do here is, now let's try to look at the data existing in the table. So let's start from defaults underscore test. And you can see that there is no data here because it's just, we just created it. So let's say insert into defaults test. Okay. Now remember this syntax where you can give the row ID, the column names. So product name is the column we want, and then let's say product price. product underscore price, and there is a row created date. Those are the columns. And let's say values. What is the values for these columns? Okay. So give me 1 second before we put the values in. Um, what we'll do here is we'll provide values for each of these columns. Now, first one is a row identity primary column, primary key column, and that is required column. So let's say, for example, this is one. And what is the second one? Product name. Let's say now we know the product name. Let's say, for example, it is, let's say milk. Okay. And what is the price? So we already know the price. It is 2.75. And let's say what is the date we are providing. So date is by default. Let's say, for example, when was the row created? I want it to be backdated to January 1st. So I can do that. And then when I run this, you can see it basically has some error here. So let's see what it is. Oh, the format of the date. I have to do 01 Jan because I had to provide it in an Oracle format. Okay, so let's run that, and one row got inserted. So now what we'll do, we'll look at the data. So whatever we inserted is displayed there. Now let's see how the defaults work. So say for example, we'll insert into defaults test, and only value I know is the row identity. Okay, I don't know anything else. So let's say, for example, values, I will say 2. And that's the only column I'm going to insert right now. So when I do that, one row got created. Let's see what it created. Okay. So now, let's see, this is the second row we inserted. So let's talk about how the other values got populated into the columns. So what happened here is we told that product name default value is unknown, and that's what you see here. Unknown is the product name because we did not provide with the insert statement. Product price is minus 99.99. So give me 1 second. Okay, so continue talking here. You can see that the default value we have for product price is minus 99.99. And that's the reason you have this entry here because we did not provide with the insert statement. Now, the next thing you can see here is the default date. Okay, so what we did with the row create date is by default it is his date. So we did not provide with the insert statement. So it put the default whatever date time it has. Um, so remember that if you have to provide these values, let's say, for example, we'll we'll put a third row in. And let's say, for example, we don't provide the row create date, but we'll provide everything else. Let's say, for example, this is a third item we are putting in bread. And let's say what is the cost is a 575 and will not provide the date. So usually in production, you will see this kind of commands where you have 4 columns, but you don't put the row create date because it will by default take whatever is the server date time. Okay. So now if you look at the data, what it does is basically wherever you did not provide value, that is a default value because the default is declared at the table level at every column. This you might not do it for every single column, but I just wanted to take an example where I cover all character data type, number data type, and date data type. All different types are displayed here. So this is how defaults are used when you want to provide default values while inserting data. Give me 1 second. Okay, so that is how defaults work. Now let's talk about column and table aliases. We looked at it before, but I just want to make it more clear by discussing about them. So let's look at the employee table. And what we have in the employee table is there are different columns here, like say, for example, e-name, job, manager, hire date, sal date, and all that. Okay. So what we can do here is let's talk about getting some columns only. And let's say, for example, e-name, comma, sal. Okay. These are the two columns I want to see. And when I run this command, it shows two columns. But what I want you to notice is this header on the top, which says ename and sal in the uppercase. Instead of showing ename, I want to show it as employee name like this. Okay. And let's say, for example, this one I want to show as salary like this. And when I run it, you can now see whatever I typed as a second thing here, it will be displayed as a header of the column. So this particular portion which I highlighted is also called as column alias. Now, what is the use of column aliases is mainly for the headers of the result set. Now that is a column alias and there is a table alias. Let's say, for example, you want to now onwards within this select statement, you want to call table emp as E because sometimes you have this long table names. Let's say, for example, every table name can be of 30 characters long. So some person has created a very long table name and in the query, you don't want to write this whole thing. Every time you have to refer to the table, you can just call it as E. But this is only for this query. Okay. So here, whatever I'm doing is a table alias, just like your column aliasing. So you're saying E name is nothing but employee name, and that employee name is displayed as a header. Only difference is the table name is not displayed anywhere, but within the query, this is an alias given to the employee name. So let's say, for example, you can do filters like e dot sal greater than, I have to do where, obviously, where e dot sal greater than 2500. Okay. So you can do this. And how does it know what is a e dot sal is? It is the alias dot column name. Also remember, you can do, let's say, for example, you can do where emp dot sal greater than 2500. Okay. So you can do that. It shows same, it gives some error. What happened? Oh, I didn't know that. So you don't have to specify this, I guess. Okay, so I can explain that. See, when you don't have the table alias, you have to give the full table name. Okay, but if you have a alias here, let's say E, then you can do this. You can do a table alias, comma, column name, and then you can write your where clause. Okay. So, so aliases are used because we are going to talk about joins. Aliases are very useful because you cannot type this whole table name like long table names everywhere in the query. Most importantly, column alias is this one. It is used as a display header for the display in the result set. And also, let's say, for example, table alias. This is a table alias which can be used within the query to refer to that table name. You can also see output in a different way here. You can see this is the output displayed. Now, employee name is not displayed completely because it is only of this length. Like employee name must be declared as a character 10. That's why it cuts off. But you can see when I run it as a query, it basically shows this employee name as the header. So that's the use of column aliasing and table aliasing. So next thing we'll talk about is joins. So far we know that there are a lot of tables. Let's say, for example, we have select star from DEPT and we have select star from employee tables. And let's talk about what Okay, let's clear this and let's actually close this, and run it as a script. Okay. So now you see there are two tables displayed here. First of all, let me also close this side part so we get more space to see the output. Okay. So here you see this is the department table, and then you have all this employee records. So these two tables are related to each other, right? How can we join these tables now? Say, for example, you want to know when you want to get the output, you want to know the employee name and the department name where they work. Okay. So the relation is based on the department number. Both tables have the department number column. Okay. So we need something called joins, right? So let's talk about joins. Let me open Notepad just to give you some theory. So first of all, when you join two or more tables, so far what we did is we just queried one table, and it was just a single table. So when we want to query from multiple tables at the same time, so that is achieved using joins. Okay. So there are multiple types of joins. So there is something called Cartesian join. There is a equi join. There is a non-equi join, and there is a self join, and there is a outer join. Okay. So these are all different types of joins you can work on. So what we'll do is we'll take most useful examples. Okay. First of all, we have to understand what is join. So let's talk about Cartesian join. What this one does is, let's say, for example, now if I remove this here and put DEPT comma EMP, and department has only 5 rows, EMP has 15 rows. Okay. So here what I'm doing is from list, you can see that um, okay, hold on 1 second. Let me go back to showing the toolbars for objects. Where is objects? Connections. Okay, that is good. So let's go back to the previous view because we don't need that much space. Okay, so now let's look at the joins, right? So what we are doing here is we have two tables, department and employee, and both of them can be specified on the from clause with a comma separation. Okay, so what happens here is when I run this command, it will do a Cartesian join. Okay, what does a Cartesian join means is every single row in the department table will be matched up with every single row in the employee table, and there is no condition for matchup. So what it does is it just puts everything out, and how the output is calculated is department table has 5 rows and employee table has 15 rows. Okay. So when you do a Cartesian join, so this particular Cartesian join will do, what it will do is it will multiply the number of rows in the tables. So 5 into, hold on, 5 into 15 is how it will calculate. Okay. So if you see here, what it did is it joins everything and it is giving you 75 rows output. Okay. So you can see in the script output, there is how do I see the results? Like see here, all rows fetched, and there are 75 rows in total. Okay. So what it will do is Cartesian join will join one row from the first table, join it to all rows in the second table, and then it will generate something called Cartesian join. Okay. So this whole thing is based on set theory in math. But what it did here is this output is useless because it just generates invalid output. Okay. So when I explained joins, basically I said you join based on a specific condition. If you forget the condition, this is what happens. Okay. In real world scenario, Cartesian join might not be useful. There are very little scenarios where it is useful. So you should know when you don't write for where clause, probably the output is wrong. So you have to be very careful while doing joins. Okay. What we'll do here is, because we talked about Cartesian join, let's talk about equi-join. Equi-join is the most important and used join in real world. Okay. So let's talk about this. What you want to do is, you want to do a where clause. Okay. First of all, let's take only employee name, e-name, right? Comma. And also I want to know what is the department name. Okay. D name is the other column we want to know. And also let's talk about getting the department number. Okay. So we know where to get this department number. Department number exists in both tables. Okay. Now what is the condition is, so there is a small confusion here. First of all, we have to figure out where this column came from. E name came from employee table. Okay. Same way, D name came from DEPT table. And here the department number will have to figure out where it is coming from, right? It can come from any table. So let's say, for example, I want to take it from employee table. Now with the where clause, what you have to do is you have to specify what is the equality between these two tables, right? So what we'll do, department dot deptno equals to employee dot deptno. Okay. So we know that the department number column exists in both tables, and that's your relation. So based on that relation, you're specifying what is your condition. And you see how you're specifying a equal condition. Sorry, let me do a, okay. So you see how you're specifying a equal to sign, and that equal to sign stands for equi-join. So you are checking what is the equality between two tables. Okay. So now when you run this, basically now you get output which shows each employee in which department they work and what is the department number. Okay. So now you got only 15 rows because now it is you can see here 15 rows. Now it is taking only employees which have the valid department, and it shows the right combination, meaning Adams research is working in a department number 20. Adams works in research department. Okay. So that is the equi-join portion of it, like where you join two tables and get the equality of that. Okay. So this is a very important example where you're introduced to the equi-join. Now let's see what is a non-equi-join. Generally, non-equi-join again is not very useful because you're saying, tell me wherever the employee department numbers not equal, right? In both sides. Now this output looks funny because it is not a valid output. Let me run this, and you can see what happens is, let's look for a specific employee. Okay. So what we'll do, we know that we have Adams. So where employee dot e name is equal to Adams. Okay. Just to understand what is happening here. And we have this other clause. Let me write it as equi-join first. Okay. So here you see that Adams works in research and department number is 20. See, this is the right output. Now, if I change this to non-equi-join, so it will become like this. It is not equal to, and then immediately you will see Adams working in everywhere. Oh, sorry. Department number is 20 from the employee department number. Okay. Let me also do one more thing is dept dot department number. So first one is edeptno. This is my, hold on 1 second. This is my column alias, and I will specify a column alias for the second column. Okay. So now if I run this command, you can see here employee department number is 20 all the time because that is what the actual employee department is. And then the department table has other department table numbers, right? But there is no record which has both of these equal because we told we don't want to see the equal number. We want to see everything else. Okay. So now it is showing a Cartesian product without showing the equality. You can write exactly same thing with a Cartesian. I want to show you a difference. Cartesian will not have a where clause. So here you will see, okay, sorry, where clause will be there, but will not be matching up the records. Okay. So there is no end clause here. Let's say, for example, we are only looking at Adam's record. Now it shows Adams works on all 5 departments. It shows as if he is working in all departments. Okay. Now, what is the use again? Because this is a set theory, all possible options are there, and you have to identify what you're writing. So, how do you know that this is a non-equi join? Because you're not equating, but you're saying whatever not equal to. Okay. So here is the identifier for the type of join. Okay. So this is a non-equi join. So let me run this again and we'll see that it only shows 4 rows. It ignores the row where both are equal. Now, if you look at the second case, here is the case where they're equal, 2020. And the department 20 is research. That's removed when you do a non-equi join because research is not here anymore. Okay. So the equality is not displayed back in the result set. So now let's talk about self join. Okay. Self join name itself tells you that if you are going to join the same table to itself. Okay. So how are we going to do that? Here we used employee and department in the previous example. Now we'll just use employee table. Okay. Just one table. And it is very important here to use some table aliasing. So what I want to do is there are 2 columns here which are very useful. The employee number and manager column. Okay. So what is happening here is for every employee there is a manager. Sometimes there are no managers, like say when it is null, there are 2 employees who don't have managers. So let's say every employee has a employee number and a manager number. Okay. So manager number is nothing but it is a reference to the employee number. So what if I want to know what is the employee name and what is his manager name? Instead of getting a number, I want to get the name of that person. Okay. So let's say Clark. Okay. Clark's manager is 7839. And let's see where is 7839. 7839. Where is 7839? Is this guy, King. Okay. So what we want is we want to know Clark and his manager name is 7839 is King. So that's what the output should be. So we have to do a self join. Okay. So first of all, let's figure out what columns we want to see. We want to see the employee number. Okay. And then we want to see the e name. Okay. So let me write it as e emp no, and then we'll say e name. This is when I say e is the employee. Okay. I will also alias the table. So here I'm going to use the same table again, but now I'm going to look at managers. So I'll use M. So now also I want the employee manager number, right? So this should be MGR, but it should come from, okay, it should, here I'm going to say this is employees details, this is employee detail, and this is also employee detail. Okay, e.mgr. Now, why I'm getting the e.mgr is we are going to find out what is the employee's manager ID. Okay, so e underscore manager number. Okay, now what else we want to know is what is the manager name, right? So let's say, for example, name should come from M table. M is nothing but the same table, but as a manager copy. So manager's e name. That's what we want. Okay. So now we'll say M e name, manager's name, right? So now how do you write your where clause? Now these are the columns you need from different copies of the table. Imagine there is two copies of the same exact table. So how you do that is by putting two aliases to the same table, and then you have to write your where clause. Now imagine, because this is now two tables, E and M, there are two tables. How do you write your where clause for an equi join? So you will say E dot mgr, which is the manager. Let's say Clark's manager is 7839, right? So this is 7839 reference here should be equal to what is m dot. M will be the employee table, but m dot e number. So this is the number how you referenced earlier. Okay. So m dot employee number. And now what will happen is it is going to have two copies in memory. It is not going to create a new table, but it has like two copies of in memory for the employee table. And you can see they're referenced as E dot and M dot. And it will decide where the columns are coming from based on the table alias here, E dot, or here M dot. And then what is your where clause? It just looks like a self join. Now, obviously, you have to work on these queries to understand how they are doing the output. Once you understand the self join very well, you will know sorry, if you understand equi join very well, you'll understand how the self join works. Now, when you run this, what we are looking for is the Clark record. Let's examine this particular thing. So Clark ID is 7782, and that is Clark. But his manager ID is 7839, and what is the manager name is King. So basically now what we did is here we are able to figure out what is the manager's name by joining the table to itself. Okay. So that's why it is called self join. We are going to we are talking about self join, and how it is possible is because we are using the same table joining to itself. Okay. Any questions? So let's talk about outer join a little bit. Okay. I'm not going to show example here. Outer join is also interesting. What you have to think of it as like set theory. So let me draw some stuff here to example of set theory. So let's say, for example, you talked about, that in set theory, you have this first circle, and then you have the second circle. Let's say I'm going to take another circle. Okay, they don't have to be equal circles, but let's say another circle of blue color. So in the set theory, what happens is they talk about this is a table A, and this is a table B, or set B, and then you have this how do you define to fill? Let's say, for example, this is A minus B. Okay, that orange thing is a minus B, and this is a B minus A. Okay, now there is a intersection here which is both common, right? So how do you do the same thing with when let's say, for example, you don't have this fill? How do you do a outer join? you want you want this portion, but not the portion in the B. So there is a left outer join, there is a right outer join, meaning you want all the records from the left table. That is a left outer join. And how do you define the left table is basically in your query. If you look at what is, imagine these are on two sides, then what is left and what is right. So left is employee E is the left, employee manager is the right. So you want all the records from the employee E, but something not existing in the right side. So that will be your left outer join, and then there is a right outer join. So there are two possibilities with that. What I would like you to do is do some exercises, do some queries, and go online and check what is the outer join. Uh, if I explain you today, I will confuse you more. So do some research and come back and ask for questions. So we'll talk about outer join later, or you do some research on that. Okay. What we'll do is now we'll talk about subqueries. So these are joins, but let's talk about subqueries. Okay. Subqueries. So you have one main query, and then you can do a you can do subqueries. Okay, so let me show you one example. Let me say let's look at the employee table for a second. Okay, EMP, and also let's see what is a department table. Select star from DEPT. Okay. Now, what is difference between joins and subqueries is there is a way you can do this. Say, for example, you want to get all the rows, all the employees who work in Dallas, let's say, for example. Okay. So how would you get all the departments which are in Dallas is by doing where location equals Dallas. Okay. So, so now what is happening here is, okay, I want to actually build up an example where you get only one row output. Okay, so let's see. Okay, hold on one second. Ignore this department table. And what we want to do is we want to get the details of the person who is earning most. Okay, so you already know that the max salary column, max salary will tell you who is earning the maximum salary in the table. Okay. So now you want to get all the details of this person. So if you think of this option here, let's say for example, you can easily do by where clause. Okay. Where clause where you can say max of sal equal to. Okay, how do you write this maximum salary? Because we cannot use group functions in where clause. Okay, so this is a very interesting question. How you will do this is, first of all, there are two queries in this. First, you want to find out. First step, you want to find out what is max salary. Okay, then how do you solve this puzzle is the second thing you have to do is find out who gets that max salary. Okay. So first query you have to write is find out what is maximum salary in the given table. Okay. So how would you write that query is this, right? So it's a simple query. You will say select max salary from employee. So by writing that, you will know what is the maximum salary. Now you have to say who gets this salary. So select star from emp where salary equal to. Okay, so this is your first query. Like you have the solution here, and this is how you're following equal to 7,300. Okay, so by typing this, you will get all the details of the employee who is getting that salary. Now, how would you make this also automatic, right? Because you don't know, it can change. This particular salary can change. So what you can do is you can take this query. Okay, let me build up a third query here, which will be the final query. Okay, so let's take that. and replace it with this. Okay. So when you do this, what will happen is you can see you got the same result. First of all, what is happening here in this query is this is a subquery, meaning you put something in the where clause and that is not a value, but it's a query again. It's doing another query. So what Oracle does is, first of all, it looks at this inner query, or there is a subquery. First, it resolves this query. Okay. And it says, okay, the value here I'm getting is 7,300, and then passes that value to the outer query. Okay. So you can see here there is a subquery. So this inner thing is a subquery and subquery of a main query. So you're able to resolve your puzzle by this two-step thing. You're able to write it in one command, one query, and you're able to find out who is earning the max. Meaning you can get all the details of the person who is earning maximum salary. Okay. Now, one thing you have to notice here, this particular inner query always will return only one value because you're looking for a maximum salary, right? So this equal to symbol will work. Let's say I will give you another puzzle to solve. Okay. So let's say, for example, tell me who works in Dallas office. So that means you're using two different tables. First of all, select star from DEPT. And what will happen is you will see that there is a location called Dallas. So what you can do is you can filter it by saying where location equal to Dallas. Now you know always that Dallas location exists and there is only one company or one department where Dallas is there. Okay. So now who works in this department? So let's say, for example, select star from employee. Okay. Where department number is equal to this particular 20, right? How do you get 20 is if you write only department number in the output here. So now what will happen is you take this whole thing and put it in a brackets. That will become your inner query for your outer query. Okay. So now you can see here, it tells you all the people who work in department number 20. Or you're asking who works in Dallas, and there is a department called 20, which is in Dallas. So that is the number of people, like you have 5 people working in Dallas office. Okay. So that's how you can see the output here. Now, also remember here, the inner query or the subquery always returns you one value, which is 20. So this is called single row subquery. Okay. You get only one row output from the outer from the subquery. Okay. Let me show you example where this will not be suitable. So let's say, for example, let's look at the department table for a second, and then I will say different inputs. So let's look at the department table, and let's say, for example, there are now 4 locations in US. Okay. So out of 4 locations, I want to know who works in Dallas and Chicago locations. Okay. Here, mainly this is based on the region. Let's say time zone. Time zone here is the central time zone. So that's the reason I'm asking that way. So easy. What you do is where location in, and you will say, for example, first one will be Dallas, and the second one will be Chicago. And then obviously when you run this, you will see 2 row output, and then you will change this to department number. These are the departments you want to see your employees work in, right? DEPT and all like this, spelling mistake. Okay. So now we have 2 departments which are in Dallas and Chicago, and you want to see all the employees who work in this department. So all you have to do is select star from employee where department number equal to you just take these two outputs and stick it in. That is what we learned about our subqueries. So we run it. Now there is a small problem here. Your subquery is not returning you one value, meaning you cannot equate. It is giving you multiple values. Okay. Just like here, you can see this where clause has multiple values inside. Just like this particular where clause here has multiple values, you have to do in instead of doing equal to. If you do in, you can compare multiple values coming in. Now it is showing you all the people who work in 30 and department number 20. So now you get this output. So initially we talked about, okay, let's say for example, we'll put it here. Subqueries, we saw single row subqueries. I'll just do SQ. Okay, subqueries. Then we are doing a multi row subqueries. So what happened in the single row is it only gave you one row output, like here. Okay, when you want only Dallas, it gave you only Dallas. But how it is one row is basically the inner query is giving you only one row output, and that is called a single row subquery. But when you had multi-row subquery, your inner query or the subquery returns multiple rows. If you just notice here, it is going to give you department numbers for Dallas and Chicago. That means there are more than one row output. And then according to the multi-row subquery, your outer query will get results for all the people who work in two different departments here. Okay. So that's how your multi-row subqueries work. There is a correlated subquery. I will cover that tomorrow. What we'll do is we'll talk about union, intersect, and minus. This is a very interesting and easy topic. So we can cover those subqueries right now. So let's talk about creating a table. I need two tables actually. Create A, and I will say, for example, age number. Okay, some column inside, and then I will create exactly same table, and I will call it as B. Okay, there are two tables, and then I will put some data inside. Insert into A values 1, 2, and 3. I need three inputs in here, 2 and 3, and let's take exactly same thing, but in the table B. So B, B, B. I'm going to do 3, 4, and 5. So I'm going to put all that values inside and commit the changes. Commit we haven't discussed about, so don't worry about it. All that data is created. So now let's say, for example, select star from A, and then exactly same thing, we'll select star from B. Okay. So now instead of joins, we are going to do something called subquery. So what is the importance here is I want to know what are all the possible ages in these two tables. That means you're going to get a union. Okay. So if you know the set theory, you will basically want everything. Okay. Going back to this drawing board here, imagine you want everything here and here. So what we'll do is we'll fill it with orange and also fill this with orange. So that is the union of both A and B. Okay. So if you want that kind of output, what you will do is all you have to do is simple thing called union in between. Okay. And what Oracle does when you run this, let me, oh, there is no semicolon here, only one end. Okay. So when you do that, it is going to put all 1, 2, 3, 4, 5 in a row. Okay. In one output, meaning this is the union of both tables. Now you remember 3 it exists in both tables. So I want it two times. If there is a duplication, don't remove the duplicates. Union will remove duplicates. If you do a union all, it will keep the duplicates. You can see here, 3 will be duplicated two times. And you simply know that table A contains 3 values, table B contains 3 values, and you got all 6 values displayed here. All 6 rows from the A union B. Okay, this is what we are looking at from the set theory. Okay, now what if you want to know only the intersection portion of it? Meaning, we'll remove all this and we want only the intersection portion like this. So what is A intersection B is the intersection area. That means what is the common values in between. Intersect is the keyword you use, and you will see that 3 is the intersection value for both tables. Okay, so that is the intersect. Intersect is basically um, what is the common value. Okay, now I want to show you one more example is there is a minus b. Okay, a minus b is, let's say for example, what is a minus b is this highlighted portion is a minus b because we don't want to get any values of b, but I just want to get a. Okay, like this. So if you also want to remove this particular thing, let me fill this here. So a minus b is only the orange portion right now. Okay, so how do you get that is by doing simple. You write minus. So you write a minus b. So that's what we wrote here. And you can see a minus b is 1 and 2. So in the same way, you can do b minus a. So you just switch the order of the tables and it will become a b minus a. And b minus a here in the representation, if you want to see what is a b minus a, your b minus a will be this. And also you will not get this portion. Oops. I think the way I did circles is also causing that. Okay. So what we can do is we can go back and draw the circles. I'll first draw the B. Oops, sorry. That was Control Z. So this is B. And then we'll draw the, okay, B. And then we'll draw A. Change the A color to orange. Okay. Now we are trying to get B minus A. That is the reason I'm doing this fill. Okay. Now let's say, for example, what is a B minus A is this, and also without this portion. The filled blue is the B minus A, and you can see the result here, 4 and 5. 3 is the common, so 3 will not be displayed in both of these cases because you don't want the common area to be included. Okay, so union, intersect, minus. Union has an extra clause called union all, where it displays even if there are duplicates. So we talked about a lot of stuff here today. We'll talk about correlated subqueries tomorrow. It is also a very important topic and very useful for writing complicated queries. And queries are like, you cannot learn everything in one day with the queries. Select statement is the biggest in the entire database. Select statement is the largest. As you use it more, you learn more. Okay. So any questions for today? If no questions, we'll continue tomorrow.